All right, mathletes, here we are looking at tree diagrams and Venn diagrams and using them to help us answer questions of probabilities. Okay, so here we're looking at two people shooting at a target. Sunil has a probability of 4/5 of hitting a target, and Monica has a probability of 5/6. Okay, if they both fire simultaneously at the target, let's model what this would look like with the tree diagram. So we're going to let S B for Sunil hits the target, and M be if Monica hits the target. So Sunil's results. Okay, she can hit the target, which is S, and we know that that is 4/5. If she misses the target, which is the complement, okay, that probability is 1/5 because we know we can do 1 minus 4/5, and we get 1/5. Okay. For Monica's results, okay, we see that she has a 5/6 chance of hitting the result, okay, and a complement of that result of missing the target of being 1/6, following the same logic as before. So with this tree diagram, notice we have a branch for Sunil's results twice, because this is the result up here if we assume that Sunil made her target. Okay, and these are results of Monica if Sunil missed her target. Okay, so with this tree diagram, we don't have equal probabilities here, so we can't just say there's a 1 in 4th chance of any one of these outcomes happening. So we have a weighted tree. So this tree is weighted by these probabilities on each branch. Okay, to find the probability of each final outcome, you multiply by the weights. So let me clear this out. So to find the probability of both of them making it, we do 4/8 times 5/6, and we get 20 out of 30 probability of them both making it. Well, if I want to know the probability of Sunil making it and Monica missing it, I do 4/5 times 1/6, and so that outcome is 4 out of 30. Following this same logic through, if Sunil misses and Monica hits, we multiply those probabilities across. Okay, and if Sunil misses and Monique misses, we're going to get 1 out of 30. Okay. A good way to make sure that you're correct is making sure that all these probabilities, because they're adding up, they're all from our sample space, their total should be 1. So notice that the probabilities for hitting and missing are marked on every branch. So you're weighting each of those branches. There are 4 alternative paths, and each path shows a particular outcome. So each is a unique outcome. All outcomes are represented, and because they're all represented, these outcomes, we know they add to 1. Okay, and again, we multiply each branch along its path to find that final probability. So let's look at one example here. So we're looking at Stefano's having a computer problems. His desktop computer will boot 90% of the time. Okay, so desktop is 90% of the time, so I'm going to make it a decimal. So then I know I'm going to have to know also what if his desktop doesn't boot. So 1 minus 0.9 is equal to 0.1. Okay. Then we're also talking about his laptop. Okay, so his laptop is going to boot 70% of the time. So to find the complement of his laptop not booting, I do 1 minus 0.7, which is equal to 0.3. Okay, so if he attempts to boot both machines, okay, I'm going to draw a Venn diagram here. So let's just, for the sake of argument, say that he starts with his desktop. So of his desktop, it can either boot or not boot. Okay, the weights of these branches are 0.9 and 0.1. Okay. Now, for the second one, we can look at his laptop. Okay, so these two branches are if the desktop does boot. And so now the laptop has two options. It can boot, it can not boot. Probability of it booting is 0.7. Okay. Probability of it not booting is 0.3. Okay. What's nice here is I'm going to use this nice feature here because this is all the same. And I can clone it, and I can see that this branch down here, so if the desktop doesn't boot, we're going to have this similar type pattern here. So use the tree diagram to turn the chance. So to finish my tree diagram, I'm going to first figure out these weights. So if they're both booting is going to be 0.9 times 0.7, which is equal to 0.63. Okay. Of the desktop booting and the laptop not booting is 0.9 times 0.3, which is equal to 0.27. And the desktop booting, or not booting, and the laptop booting is 0.1 times 0.7, which is equal to 0.07. And both not booting, it's 0.1 times 0.3, and that's going to be equal to 0.03. Okay, notice if we add all these together, they add up to 1. So now I can better answer these questions and B. Use the tree diagram to determine the chance that both will boot up. Well, both booting up is this path here. So we can see that it is 0.63% chance of happening. Okay, only the desktop computer boots up. So that means we're going to have the desktop computer boot up and the laptop computer not boot up. So that's that branch. So we see that probability is 0.27. Okay, so tree diagrams, weighted tree diagrams can be very useful in this problem-solving strategy. Next strategy we're going to look at is with Venn diagrams. So here in this example, we're looking at spinning the spinner. Okay, kind of looks like a roulette wheel that you might see at a casino. We see that we have digits from 1 to 20 presented on this wheel. Okay, so using our Venn diagram, we have two sets of numbers we're talking about. Okay, let A be the set of numbers when we're spinning an odd number. Okay, so that's set A. And I'm going to put odd here just to remind myself. And then I have set B. So set B is the event spinning a number greater than 13. So B is greater than 13. Okay, so I know my universal set, okay, is equal to all values such that they're from 1 to 20. Okay, and we're only dealing with x's that are integers. Okay, so as I'm thinking about these, I want to put in the values where appropriate. Okay, so first I always like dealing with the intersection. So what are my odd numbers greater than 13? Well, I'm going to have 15. I'm going to have 17. I'm going to have 19. And I'm there. Okay, now I'm going to worry about all the odd numbers that are 13 or less. So I get 13, 11, 9, 8, not 8, odd. So that is going to be 7, 5, 3, and 1. Okay, and then I'm also want to list the numbers that are greater than 13, but the even ones. So I'm going to have 14, 16, 18, and 20. The last is list the ones outside of both sets in A. So I think of even numbers, okay, that are less than 13. So I'm going to have 2, 4, 6, 8, 10, 12, and then I should have all my numbers there. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I got all my elements in my universal set. So now that I've represented this problem with my Venn diagram, I can better answer a question about finding the probability that the number spun is odd and then greater than 13. So find the probability that the number, so probability that the number spun is odd and greater than 13. So remember, this is a probability, and is the symbol of the intersection of probability of A intersect B. Okay, well, probability of A intersect B, I see that is dealing with my red numbers. So there's 3 of them in there. Out of how many numbers I had was 20. So that's the probability that the number spun is odd and greater than 13. Okay, let's look at one more example here with Venn diagrams. So in a class of 30 students, 19 study physics, okay, 17 study chemistry, and 15 study both of these subjects. Okay, so I'm going to put a P here for physics, and I'm going to put a C here for chemistry. My universal set. So now I'm dealing with numbers, so I'm going to remember to put parentheses. I always like to start with the ones that are in the middle, studying both, okay, physics and chemistry. So I have 15 students here. Okay, now working backwards, I know that 19 study physics, 19 students study physics, 15 study both, so 4 study just physics. Okay, that same line of logic, notice 4 plus 15 is 19. So 17 study chemistry, 15 study both, 17 minus 15 is 2. Okay, and remembering the brackets, and that helps out. Okay, the last piece of information I got to use is there's 30 students total. So I know that all of the elements have to add up to 30. So 4 plus 15 plus 2 is equal to 21. So I have to have 30 students in total. So 30 minus 21. I'm equal to 9 students that study neither chemistry or physics. Okay, now I have my Venn diagram completed. Okay, determine the probability that a randomly selected student studies exactly one of the subjects. So exactly one of the subjects is either just physics or just chemistry. So we have 4 plus 2 out of our 30 students. So that's 6 out of 30 for the probability of those. Okay. C is a given statement. So the given statement is I know something going into this. It's conditional probability. So I know that my denominator is going to change. So given that a student does not study physics. So if I know that the student does not study physics, okay, we know we're only dealing with these students here. So now, because of that, I'm only dealing with the 11 students. So now I want to determine the probability that that student studies chemistry. Well, how many students study chemistry that don't study physics? Well, that's 2. So our probability is 2 out of 11. That concludes our notes tonight. Please highlight any questions you might have and bring them to class tomorrow.